Okay, so I'm making a horrible mess. This is supposed to like connect. How many? How many ways right now? I think three actually exchanges at least like more. I'm trying to do a generalized thing that unifies the exchanges, and
Uh-huh.
yeah, it's not fun. It's very not fun. So I like right now I rewrote the architecture a bunch of times already, but right now the thing is like I have generics for um, messages like HTTP things which they usually expose, WebSocket stuff which we usually expose. Then I have the implementations for specific exchanges. So this just defines like a bunch of shortcuts given the how are they called, the options, right, for each which each client supports, and then shortcuts exchanges. This is just mind fucking numbing. So yeah, yeah,
Fail.
it's not fun. This is not fun, and I've still like halfway. It's still painful. So then I have the Distore thing, which is there is nothing here. Essentially, for now, it's just starting. It's going to be like fucking 20 times more. But the idea is that here we take the standard methods. Well, this, well, theoretically, right? In the perfect world, I have all the methods which Exchange provides, but I can't be fucking bothered. So I'm gonna have all the ones which I use. Then there's gonna be like
Mhm.
there's some fun things that you can do is to have like automatic checks. So basically, you could make a system which would make these calls, then store the responses like time to time, right? So like a long test. Then so we actually make on the test network those calls, get the results, we store the results, and then run tests against the cached responses previously, and so we check that all the current fucking disorder things match it.
Mhm.
And this is like no, this particular system would be fun to do, but defining the rest is just Jesus Christ. I mean, this you just practically read the API documentation, and you fucking make the deserialization so it just matches the names match,
Mhm.
and that's yeah. I've been suffering, and it is a complete mess. Like because of how much code there is, and I can't be bothered to refactor any of it. Yeah, yeah. So, but that's the idea.
Well,
So we have the and this is currently this is just plans, but it's going to be for exchanges, and then it has like a client where you can define options, you can create it, define options, and then you can define options per request. So like response time, which you can tolerate, for example, on like
mhm.
opening order, and then specific to the request options, whatever. But this is kind of trivial, and then yeah. So this would just basically take care of having all the things deserialized and usable in Rust as Rust native structs. Uh, and
Right, so
then
the thing is, what it sounds like to me, the issue you're having is that all of these trading platforms send you the data in different formats,
no, actually,
and
it's reasonably good, but the problem is that they are not the same because there's like
yeah, I mean all those have different APIs, right?
exactly, and it's
Right, and then you also need to get the data in somehow a unified way. So dumb question, isn't this like a prime uh, opportunity to use Java-esque virtual inheritance?
why no why
I
why
mean, you all you need to do is to have a base class which implements all of the sorts of things you want to have it implement, and then just derive from it a class for each of the specificities of all of the APIs. And that way, what you get in the end is you're just dealing with the base, and in the
Oh no
background,
no no no
the
no no. Okay, so in Rust this is also like trivially doable with enums and drives. So if you
oh,
look at
you're gonna
like
use the enums.
you have yes, and you have good drives here. I'm not sure. Fuck it, whatever. So this
Yeah,
one,
you
for
just
example.
really hates object oriented, forces your hand
No,
into the
no,
function.
no,
It's
no,
like
no, no,
what
no. Rust is very happy with, because like object oriented is a fat word, okay? This uh, like for example, look, this is this your thing, right? We have names, so this will come with like t value, and it will come as a string, for example. So I just slap store the s, and it will also deserialize a string into f64. We have a very nice frame. Well, okay, not very nice. Certainly has its own problems. There's a guy who's making like a better library, but that's questions of the future. But even now, it's pretty good. You just slap the like targets on everything, and it deserializes, and it's good. It's good. Like for example, this thing, right? It's just like you have a string, you have a bunch of values, and it just deserializes into the where is it? I think it's here. There you go.
Mm-hmm.
And that's it.
Right. So as far as I understand, this program of yours, it basically talks to a bunch of APIs, gets responses from these bunches of API, and tries to make them in a to put them into a uniform type, which your program can then deal with and make decisions based on.
Yeah. It's exposed to other things because currently, like in every single one of my things, I am basically doing it from zero. So if you look at like get, where's get? I want to get. No, not this. Where's get? I want to get. Is this? No wait, this is params. Who makes a call? Who the fuck makes a call? Where are my calls? Actually, let's grab for. There we go. So for example, right? I'm just like in place. Like this is okay. This is very old part of code. It's very not good. This is the ultimate spaghetti. So I'm just getting like very quickly, very dirty bunch of balances. And here I'm making like on the spot. I'm making the full request. So this function, right? This function. Wait, I made a shortcut. Made a Vim thing. So GWZ opens it. Yes. Okay. More optimal Vim shortcuts. Now, this is a thing which, well, does some error handling in a nicer format, doesn't matter, but effectively just makes a standard request, API request, with like standard stuff, right? And the rest I need to construct myself, so I need to provide the full input struct and then interpret the string which it returns in place.
This is like the
like it's bad. Like for example, like this return string, right?
Single. I mean that the style of coding, by the way, is the antithesis to the single responsibility principle.
Yeah, this is very bad code. this is very bad code. So yeah, and like I'm doing this on site. I'm deserializing it into the target struct, and just like the error handling is bad. Like this is effectively all I have. Like this is literally all, because if I were to do it further, in every single project it just doesn't scale. I cannot do this. If I had like a team of 10 people, sure, but you know, it's just not an option.
Yeah, I understand. And the issue with scaling is right that you would need to manually implement the same for every single API, right?
Yes, exactly. And then, like, if I'm doing it on site in the project, it's going to be different implementations for different APIs. Trust me, I tried. It was like I killed like this first.
Yeah, I understand that, but
I tried the Rust.
But I'm seriously feeling like at least generics, if not virtual inheritance, would be helpful to you.
No, yes, I have generics. I can show it again. By the way, I think I haven't introduced to you randomly appeared. We are 9 minutes into the recording, so this is my friend who's incredibly good at math. That's all I get. Okay, now so generics, right?
Like what I'm thinking as is not thinking as Jesus Christ, I already got you cancelled. What I'm thinking of is having your API be some sort of object and getting passed into your function as a
yeah. That's exactly how it's gonna be. So it's exactly how it's gonna be. So okay, look, this right, this thing, it kind of already at this point we have it like the interactions themselves, the points where we talk to API, they're standardized, they're generalized here, right?
Mhm.
So this defines them, these specific implementations for specific exchanges. Now the definitions of these are right here. So for example, this again HTTPC, right? And we have a bunch of definitions of how requests, like what in essence they are, right? And then a bunch of shortcuts.
Right.
Like good
So
stuff, requests, like
I guess what
this.
you're trying to figure out here is what are the primitive, quote unquote, primitive functions which a API is required to be able to implement.
Partially. So
Right.
what I'm
So
right here, I'm merging everything into one, like into the part which is shared across all exchanges, and just
right.
normalizing the base struct. So I'm gonna have I've just started like
Yeah.
not just started. The previous version was complete mess, so I had to like remove all of it. Right now I have the bare. You wouldn't believe how bad it was.
Yeah, I can relate.
So it's yeah. I have like I don't have
See,
shit like
Rust,
commented
to
out,
your
but
viewers, Rust doesn't stop you from
I don't
making
have
bad
viewers.
programming decisions and refactoring
Yeah, no, well,
like a maniac. So
yeah, no, of course, of course. It's just when you're working with money, it's very nice to have something safe and not
quote
lose money.
unquote safe.
It's close. More safe. It's more reliable, right? It's more difficult. It's more difficult because it doesn't make sense to just judge everything in black and white. It's slightly more safe, right? All in all, and that's not, and especially for like large systems, when I'm making something huge, it scales very well because it's very defined. Like good C++, like good C++, right? And standard Rust can scale very well because the types are so incredibly precise. It's very easy to kind of separate
Yeah,
responsibilities and
yeah,
define
it's
very
tricky.
finely the boundaries. So, but doesn't matter. It's if you start talking languages, that will take another 20 minutes.
Yeah, but so I understand that you're trying to force everything here into, let's say, a
So,
common type, right? So that you
yeah,
can.
yes, it is a trait. It's a trait. So basically, we have an
Oh.
we say that an object. Traits are fucking amazing. Like I deleted everything. This is practically nothing. So this for now, like I'll start out because I re-engineered again. As I said, this has trait just for now has one single it will have more, but this has like clients fn, which we can call and get an object of type clients. And this object will be standardized, so I will have like a translation layer for each exchange. What we defined previously, how every API, what it should return, right? And then we translate it to Rust terms, and then we take these Rust terms and then translate it to the standardized thing. And it's not going to be one-to-one. Like later on, I will add
Do you
additional things.
really
Like
need to even translate it to the standardized thing? This is what I'm trying to
yes,
say.
because it's different. It's
Java
fucking
is.
different for every single exchange. And if you add like layers of translation, it will have artifacts of things which it came from. For example, like it's this is not a big problem, but like even it's one of the most obvious. For example, this thing right has ignore in it. You see this ignore thing? API returns ignore.
Yeah.
And then I will have this in the end struct, like it doesn't make sense. And then again, there would be different. And if they are different, you cannot have, like it's very difficult to make functions on top of it because everything uses clients in my programs and not having it standardized is
Yes,
just
I
crazy,
understand, but
right?
yeah, but why not have the standardization be a base class and then just return derived and only pass around the bases, which are standardized, but not bother with the translation. Rather, the derived should just implement all the stuff of which the base implements, and then implement it once, and then you have it for all times wherever you have the base. That's like what I'm trying to say, but
This
feels
is
like you're not too on board with the Java method, so I don't know.
because this is only used once. This is used when you talk to
Okay, it's
the
worth.
API. I don't want to carry around the state from the API. I just want to like get the information about the price and then not touch the API later because it's just like less state to work with, right?
Yes.
This is well-defined thin waste to just like what data passes over to analysis,
Mm-hmm.
and that's it. That's gonna be it. So I'm just gonna define like a bunch of things which are shared and then translate the shit.
Right.
And then like one good part of it, right? Because now not gonna be limited to what API exposes. So it's going to be like rather easy to just make methods which would allow to request a shit ton of 1 minute time because here like most API requests are limited to like five like normally thousands of individual points, and then you need to kind of stitch them together yourself at the moment when you need it, and it's it takes time, it takes synchronization. You need to think about like rate limits. You can do like
I think,
proxy swapping, and
yeah, I
it
think,
starts to be crazy. But like now we can implement it right here, right? And it's going to be just additional methods, which kind of the same interface, right? And then
yeah.
it really make it so much more scalable for all other things which use it. And I'm excited to the result. I'm not excited to continue doing this because so far it's been incredibly boring.
Yeah, you're gonna have to build it in a way which, there was recently a talk in the C++ world, which I think applies to the Rust world as well. It's called the principle of minimum surprise, meaning that e- every function, every type, everything you make should have as little in it as possible, so that it's as modular as possible, meaning as scalable as possible.
Yeah.
So I don't know, but I've been peeking here into structs which have 3 fucking public fields, which all are like composite types, options of
Okay, this
results of
public fields are not
options.
here for long. This is just like debug code. Okay, this is. I'm not gonna have like public fields. By the way, why the fuck is it here? This shouldn't. What the fuck? It's,
Okay, that's well. There you go.
it's,
That
I
was
mean,
a surprise.
thanks. That yeah. Okay. Right. Yeah. Actually, this makes sense because I could again. I'm one sole dev, right? I could add methods to make it nice and clean with methods to get the things, and you could say that it could be better. But I'm honestly in this case, like for
The
example, for
question
client,
is,
I will just leave it as
are
is here too.
those
It's fine.
the question is, are those 3 fields or like say the general thing which I figured out whenever you're making a type, especially regarding the fields, uh, you need to think about, are they really inseparable, these fields, right? So when you have a point in 2D space, then you have two coordinates which really are not separable. But do this vec of Klein, this time frame, and vec of OI, whatever that is, do they
Open
really
interest.
inseparably belong together?
Yep. Yeah. They do. Yeah. No, that
In
makes sense.
that
Of
case,
course.
then this is the correct
Yeah.
answer.
Yeah.
So
Makes sense. Yes, of course. Uh, yeah. I always try to think through
it's
this.
of course also a performance consideration. If your structs are big, passing them around is expensive.
Not only it's also like thin waste question, right? Because you can have many things
Yeah,
just communicate through a smaller
yeah,
number of but
yeah.
obviously this is only concerned at the boundaries because doing that
Right.
like throughout the
Yeah,
interconnected parts of the code doesn't make sense, but for boundaries especially, yes. Anyways,
yeah,
that's I think that kind of explains what I'm doing. I'll
yeah.
see you tomorrow.